times 2 because I read the values wrong. I can fix it quickly. Okay, I changed it and it's actually 4.14 ohms. 4.14.
Wait, how? So it's 5 times 3 divided by 5 plus 3 plus 2, right?
No, not 2. See, that's where you are mistaken. It's 5 multiplied by 3. I mean, initially,
Yeah.
then you will do plus.
Yeah.
So 5 multiplied by 3 plus 3. So it is basically 15 upon 8. What is the value?
2.14.
2.14. This is the equivalence. 2.14 is the equivalence of R2 and R3. And then definitely, as Alicia said, you will add these two and you will get 2.14.
4.
So
Plus
it will.
2.
So 4.14 is the equivalent resistance.
Yes.
Okay.
Is my I3 equal to 1?
I3 or R3? What are you saying?
I, current.
We need to check it out because this is a whole.
Voltage is equivalent to all components in parallel. So R3's voltage is 5.
Let's see
And
quickly. This is 4.4 ohms. The current will be how much? I is equal to 5 upon 4.4. What is the value?
oh, I'm supposed to use my R equivalent answer to do this.
Of course.
I
Without
thought
this.
I couldn't. Okay.
So
So
what
you
is?
find the total current and then
You have to shift back.
divide. Yes.
Wait, I
That's what
have a question about
that's
the resistance R effective. How is the answer when you divide 15 by 8? How is it 2.14? Isn't it 1.8?
I don't know. You tell me. 8 1 divided to the
It says
16.
in the calculator it's
It
1.875
is. Yeah.
plus 2.
It is 1.87 actually.
is it?
Yes, it is.
Eh,
But wait.
So your answer is
maybe you
absolutely.
typed it wrong.
No, it's 15 over 7. Oh wait, no, I wrote 5 plus
Yeah.
2. That's why.
Alicia, you're right.
Again.
Okay, now can you find out the current value for me, please? The I equivalent or I total current, whatever. V upon R, which is equal to 5 volts divided by 3.87. So what is the value?
1.4.
1.4. Now this is the current value, the total current, right? Now you have to shift back and you have to say this voltage and this current. Definitely current is being, it's a parallel circuit. So parallel circuit means these two and this one, the voltage will be the same. So you can say that V1 and V23 is equal to V and which is equal to 5 volts. Now, as I told you, power through R1, you already know V1. So I think you better use this formula. So this one will be P1 is equal to V1 square upon R1. So it is 5 square divided by 2 ohms. So 25 divided by 2 is equal to 12.5 watts. That is your first answer. Okay. I just used a power formula, nothing else.
Wait, I have a doubt to calculate for calculating I3. Why are you using 3.87
As a
as
what?
the resistance? Shouldn't you use like the resistance of R3?
See, this is all the step you need to follow because we have to find because you know once you find out the voltages and everything, they all combine. So this current needs to be found very importantly because this current will tell you that your current value will not exceed them from them. And one more thing, And sometimes, the current has to be divided or current has to be same. So you better find out current at each and every step. Otherwise, sometime in the middle, you will be confused what to do next. Like now, I'll tell you one thing. V23 you found out, okay? Now, what is your R23? It was 1.8 at this point.
I just 1.9.
This one, right? So basically, your I23 will be equal to V23 divided by R23. So V23 was how much? 5, because it's a parallel combination, and divided by 1.87. So what is it?
What is what?
See, the voltage across V23 is 5 volts, which I just placed it. What is R23 value? R23 value is 1.87. So I need to find out the current through I23,
It's 2.67.
2.67. But you know one thing, the problem here is the current value is 1.44. So basically, it's not possible that the value should be same or whatever. So it means that there must be some issue in this. That's what we need to check. When you say V1, V23 are same, we find out the V2. Okay, wait. At this point, there is one thing. Because voltage was absolutely in the series. That's where the problem started. If you do step by step things gonna be easy for you. Just remove this
I
and
was
check it.
thinking, wait,
No?
so current is the same
Yeah,
across
that's
each component in series, right?
yeah. I put the voltage same. See, that's what the point is. So it means that instead of technically, I have to write I1 equal to I23 equal to I, which is equal to 1.4 amperes. That was a statement I had to write.
Yes.
Now, at this point, I can very easily go for current I. So formula for PI will be I1 square R1. It is 1.4 square and the resistance R is 2. Can you tell me the value for this, please?
It's 3.92.
3.92.
Yeah.
This is the watts of the P1. Now, what else you need to find out? Let's check it out. You have to find out I3 and V2. I3 and V2. Now, let's do that. I23 is known already, so let's go for V23. So V23 is equal to I23 multiplied by R23. I23 is 1.4, R23 is 1.87. So what is the value?
2.62.
Okay, 2.62 volts, right? We are still on the second. Now we know that this V23. What is this combination? It's a parallel combination of 3 and 5. In parallel combination, the voltage remain the same. So I can say that V23 is equal to V2 is equal to V3 is equal to 2.62.
Yes.
Now, very easily, let's start with I2. We have to find I3, by the way. So let's go for I3. I3 is equal to V3 upon R3. V3 is 2.62 and R3 is equal to how much? 5.
R3, 5.
So it is 2.65 divided by 5, which is equal to.
0.52.
Actually, you found out
Yeah.
everything. I3 is known, V2 is known, everything is.
So we ended up having to find everything, even though it wasn't required.
Yeah. But sometimes you have to find out those things which are not even required. Actually, it is a part of the question anyway. Because if without finding those things, you can't find the ones which is required. But once you stuck, you never need to stuck. Find out in each and every step. I mean, the easiest way to solve this question is in each and every diagram, in each and every combination, find out all the three things. The resistance must be known to you. So you only need to find the current and the voltage of that particular resistance, whether it's a combined resistance or whether it's a individual resistance. Okay.
Okay.
So I'm giving you a homework, and in the next class we will do one or more two things related to that, and then we will jump to waves. And next class will be for you with the Mahnur. Okay. So last two
Mhm.
classes, one is for 2 hours and one is for 1 hour. Then okay. Now this one. Now resistance is here. You have to start from the far, so these two are the one best choice for you. And this is 5 volts. Again, I don't want you to find everything for me. V3, I want you to find out. I2 and the same R equivalent and power consumption of R1.
This is homework, yeah?
Yeah, that's it.
I have one question.
Please.
What if we are not told all of the resistances?
Again, what you said?
What if we weren't told one of the values for the resistance?
See, in question, the resistance value must be given to you. Otherwise, the resistance will not be that much complicated. Okay. You know, if the resistance are not given, then some value of current will be given to you. There must be some
Yeah.
value which will be given to you. Otherwise, how will you proceed with the question? You know, the last question we have done for the what you call it, internal resistance. They have given us the value for the current or internal resistance value or something, so that we will be able to find out the total current or something. So they must give you
Okay.
something to find out the value. In this case, you are provided with all the resistance and voltage, and then you have to find out the current. Sometime may be possible they provide you the current value, but they will not make the things difficult for you. It will be simple series parallel circuit, and that's all.
Okay.
Okay. So we will start our class A. In the next class, we will start from here. There are one or two very small topic related to electricity, and then we will jump to waves. All right.
All right.
Okay, then I'll
Okay.
upload this class as well. So if somebody wants to see that, they can just simply talk to coordinator and they can see that as well. Okay.
Okay.
Okay. Take care.
Thank
Bye.